There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Factoring Grid. This module is a 6x6 grid of numbers that have the range of 1 to 3 digits in them. And what we're going to be doing here is actually going to be very simple. So what we're going to be doing is we're going to be trying to form a continuous path throughout these numbers on the grid. And there's going to be no loops or intersections in this at all. Each number must go through the grid, and must go through each number in the grid except once. That's the way that this is going to work. So, a number can only be connected with another number if they are orthogonally adjacent, and the connection between the two numbers is only valid if they share a common factor larger than 1. So this is the way the module is going to work, and what we're going to have to do here is we're going to have to figure out where we can start and what we can do to do this stuff. So, immediately what I'd like to do is I like to look at the corners, because the corners are a very good place to start. And it generally is going to be just a good place to start. And another nice clue is going to be similar numbers. In this case, if we take a look at this top right corner here, we notice for a fact that the 1, 2, 3 and the 1, 2, 3 corners exist here. So likely what's going to be happening here is this is going to just be a little bit of a corner that's happening here on some part of the grid as well. So that's going to be quite nice. And I'll be honest with you, I'm going to be using the Google search of factors of just to give you guys an example of how it actually works. You can use the calculator if you so please, but this is just explaining how the module works. I will be using the calculator for some portions for some simple calculations just to make sure. But for bigger numbers like 119 and stuff like that, I'm not going to bother looking around for some of those because that's a bit weird. And it's like a prime factorization stuff that I'm just not too familiar with. So let's have a look and let's see what we can do here. Now, another good clue that might give you some helpful hints is if we have a lot of even numbers around, and this could be a lot of areas, but I wouldn't necessarily jump to the conclusions with this one always. There might be some blatantly obvious spots, like for example, like a 3x3 grid of just even numbers. That might be helpful. However, I would still take into consideration that could be misleading. So let's take a look and let's see what we can do here. And they kind of just start to go off, honestly, all over the place. So let's do that. And with the 25 here, with the 10 and the 30, these all have a factor of 5, so these corners would work. That could potentially be part of our pathway. This is a factor of 5. 95, factors of 95. It's a bit interesting. So let's take a look. I'm going to start using this thing where you just search up factors of insert number here. And it's going to be 5 and 19. Now, is 114 divisible by 19? It is. They do share a factor. Now, is that the same case with... actually, it should be. 114 plus 19 is not 123. Factors of 114, though, let's find out. What do they share with 123? Actually, quite a bit. So 123 is probably going to be a bit better to search up here. Is 41... Factors of 123 divisible by 3, maybe? 114 divisible by 3? It is, so they do share a factor. So that could potentially be some good starting points. Now, reminder that within this case, what we happen to do here is we cannot go to any of these pathways. This is not an intersection because this is going to be what we're looking at here. We cannot do intersections in this module. It's not the way that it works. It needs to be one continuous pathway. Now, for 111, 111 should be divisible by 3 because we just did 114 being divisible by 3. So that should be good to go right here. 170, is that divisible by 3? It is not, so we cannot go that way. So 148 divisible by 3? It is not, actually. So this actually might be the beginning of our pathway here. Because of the fact that we have to check some of its other factors, though. So 111 is divisible by 337. Is there any of them divisible by 37? Divided by 37. Not that way. And 148 divisible by 37? It is. So this actually could be the way. That would work. 37 is the common factor, so you got to be very, very careful because it's very easy to say that, oh, one of the low numbers doesn't apply, therefore it doesn't work. But that's not necessarily the case all the time. The factor of 2 can apply here for even numbers, and this is potentially a good start here. 30 and 30 might work together. This might be a factor of 5. This could also be a factor of 5. These all are factors of 5, as a matter of fact. And for 25, 5 times 5 is only 1, 5, and 25. And we know for a fact that the 25 cannot go up to the 29. So therefore, I actually believe that this forces the 30 to come down here. Okay. Factor of 87 and 145 might be 3. 145 divided by 3 is not divisible by 3, so we actually could go somewhere else. Let's take a look at 87. Let's see what else is divisible by, or 145. 29. 87 divided by 29. That does work. So that can be a pathway right there. Now we got to get into the nitty-gritty of the center bit here, and this part's a bit fun. Not. Now we know for a fact that the 129 cannot come up from the 4 here. So what this likely means is it's going to be like this. Now for 129, what factors of 129? Let's see what we can do here. 86 should be divisible by 43. Yep, those combined together. That's perfect. And it's divisible by 3. 172, is that divisible by 3? It's not. So 172, factors of 172. What combines these guys together? Because this could affect a lot here. 43. So 129 divisible by 43. Yep. And 172 divisible by 43. Big numbers like that, you definitely want to focus on those. That's even. They're both even together. This is likely a factor of 3. 170 divided by 3. It's not. What else could it work with? Factors of 51. 17. Yes. 17 times 10. Yeah. That would work. I think I could see a potential path. All of these are divisible by 2. And then we determined that 172 and 129 go together. Divisible by 3. 119, is that divisible by 3? 119 divisible by 3 is not. It's not divisible by 2. Ooh, hold on, let's be careful here. Because if we force it into 119, I don't think it shares any factors with 119. Let me check. Yeah, 7 and 17. So this actually might be the start of our pathway. I need to be careful here because we don't have that much options left. The 15 and the 6 I think would work together. But we need to make sure that we're careful and we check. Look, factors of 85 shouldn't be that many, but let's make sure that we can divide by 51 divided by 17 should work. Yes. Okay, so 17. 136 divided by 17. Yep, that works. So 119 again. Let's check. 136 divided by 7. 17. Yeah, that's 17 more. 136 divided by 17. Cool. So yeah, that would work. And I believe that this is the end of our pathway. And I actually think that this works. Because it's one continuous path. It starts from the 6. It goes up and around. We follow this way. It goes up and around the corner. It goes down and then to the right. And then it hits every spot. That should be it. And just like that, and as you can see, it follows the pathway that we built, which is exactly what we needed to do. So that's all there really is to it. It's a very simple mod, and I would advise doing this in a team element interactively. It's a very, very good thing to do. And that's really it. I'm going to do one more example just to show you guys how this works. But generally, you kind of just start to go off and kind of all over the place. It's not that hard to do. And there is some stuff that you can definitely figure out along the way, and it's pretty easy because it's just following a path and building it. Obviously, adjustments might have to be made somewhere down the line, but for the most part, it's pretty straightforward. Yeah, just make sure it doesn't loop, and that's going to be a big hint for you because of the fact that like looping is a no-no. Thankfully, we were able to figure out what the 6 and the 119. They had no common factors at all, so that made my life a lot easier. So, let's have a look at our last example here. Hopefully we get a bit of an easier one. 35 and 56. They both have this is a factor of 7, this is a factor of 5. That would work together. This is a factor of 118 by itself. These are even. This could be another Easy case of the corners. 62 and 65 though. It might actually be down here. It might be like this. 86 and 115, but they both divisible by, they gotta be divisible by something. 86. Why I close this page? 86. 43. 115. 155 divisible by 43? It is not. Okay, interesting. This 155 is interesting. 155. 5 and 31. 124 divisible by 31? It is. Okay. I might actually not want to go this way. Use a factor of 5. This would work. We don't want to go this way because that's going to cause a loop, and that's not going to work for us. Actually, no, that could actually help for us. Even, divisible by 3. Not divisible by 3. Even, divisible by 7? 177 divisible by 7? No, it's not. 177 divisible by 14? No, it's not. These go together. 91 divisible by 7? Yes, it is. 91 is 16, 26? Divisible by, not by 3, factors of 26. 13. They're both divisible by 13. 91 divided by 13. 7. 26, 141 divisible by 13? No. What are the factors of 26? 2, 13, and 26. Ooh, okay. We know that those go together. 1, 4, 1 don't share any factors. Yeah, okay, that's interesting. Is 1, 4, 1. Divided by 3 is 47. Yep. Maybe what it could be. Bit of a strange proposal, but it could be potentially a detour that we need to take from the 94. 177 divided by 3. Yeah, so they're all factors. They all should go together, as far as I'm aware. Yeah, some modification is definitely in order here. We're close. I can definitely tell that for sure. The question is, what do we need to do? 94 divisible by... It's not divisible by 3, but what is it? What else is 141 divisible by? 47. 94 divided by 47? Yeah, that works. They are definitely combined together. 177, factors of 177, divided by 59, 118 divided by 59? Yeah, those go together, absolutely. Something like this. Go down here, maybe. 26. Not divisible by 3. It can't be that. This one's interesting. This one's a bit interesting. I'm gonna probably get rid of this bottom bit because this definitely is gonna need to be reorganized. But we know for a fact that actually this path happens. We don't know which way it's gonna happen though, because I might need a little bit of room here. Bingo. There we go. So go to the 26, go all the way down here, go here, go here, go here. We determined that those were good. That's actually a problem still. Close. There's got to be something else I'm missing here. Maybe we get rid of the 70 bit and we go here, maybe? Something like this. These are all still even. We do something more like this, perhaps? Wow, this is rough. Okay. Okay. So we know for a fact that this has to be our starting position. We know that this is guaranteed. It has to be this way because 26 and 141 do not share anything. Yeah, we know that for a fact. So it has to be, this has to be our starting location down here. This makes life a little bit easier to work with here. Still very tricky on its own merit. 38 and 57 even share anything? Hold on, let me check that. 38. Yeah, 19. Shouldn't be 19. 57 divided by 19. Yeah, okay. I'll obviously divisible by 3. Oh my god, I found it. Yep, there we go. So it starts here and it ends over there. Should be good to submit. Just like that. It's a very sneaky one. But it started over in the bottom right corner, went all the way up. Wow, that's crazy how it did that. Yeah, it's a cool mod. I like the way that it does that. It definitely is a bit tricky at times, but absolutely you just gotta try things, and yeah, that's really all there is to it. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.